Welcome to the Explainer. Today we're undertaking a really intensive deep dive masterclass. We're going to take you from being a complete novice in AI systems infrastructure right up to an absolute master-level practitioner in AI tokenomics and FinOps. We'll be looking at the exact systems that let you take those generative LLM applications from simple, shiny prototypes and scale them into safe production architectures, without completely burning down your company's balance sheet in the process.
So let's hook right into our first big provocative idea. Why did your AI prototype just bankrupt your cloud budget? Seriously, what happened? Well, for years, the tech industry has operated on this very predictable cloud financial management model. You paid for known quantities, vCPUs, RAM hours, storage tiers. It was safe. But the stochastic, highly variable nature of AI tokens has entirely replaced that predictable billing model. Today, a simple code update on your end can suddenly trigger thousands of hidden background processes, spinning your costs completely out of control before you even get a Slack alert.
Okay, here is our roadmap for today. We're going on a progressive 6-part journey. 1. The core foundation of AI tokenomics. 2. The agentic cost explosion. 3. The AI gateway layer. 4. Advanced semantic caching. 5. Dual brain architectures. And finally, number 6, the AI FinOps future.
Let's kick things off with Module 1, Core Foundation, AI Tokenomics. To really get this, you have to think of a token as the actual gasoline for your AI engine. In this new world, you aren't paying for compute time, you're paying for the fuel consumed during an inferential act. And unlike simple word counts, tokenization actually chops bytes into subwords using algorithms like byte pair encoding, or BP. This is a brilliant approach because it elegantly balances the vocabulary size with representational granularity. It's what allows the model to efficiently process rare words and super complex code. But remember, every single time you send data into that context window, you are burning fuel.
Now check out this super durable rule of thumb that you'll see all across the vendor environment right now. Output tokens cost roughly 5 to 6 times more than input tokens on current flagship models. And that ratio? It isn't just random pricing. It holds true across different providers and different generations of models.
So, why the huge disparity? Well, here is the rigorous computer science reality behind that price gap. Input tokens, meaning your prompts, are processed in parallel. The model's attention mechanism basically reads them more or less all at once. Output tokens, however, are generated autoregressively and sequentially. The model literally has to predict one token at a time, with each new token completely depending on the entire sequence that came before it. Reading in parallel is computationally cheap, writing sequentially, incredibly expensive.
Which brings us nicely to the vendor landscape. Just look at how premium infrastructure providers like SambaNova offer this incredible throughput, but they command higher fees, around $5 for input and $7 for output per million tokens. Conversely, you've got budget models like DeepSeek that can drop those costs by 3x. But you're going to pay for that discount with increased latency and much slower decoding speeds. It's a classic trade-off.
Moving right along to Module 2, the agentic cost explosion, multi-agent workflows. Let's see how all this builds into absolute chaos when we move from simple chat to autonomous AI agents.
You really need to anchor your strategy to this staggering metric. When researchers analyzed agentic coding tasks, they found that they consume up to 1,000 times more tokens than simple code reasoning or chat. 1,000 times. And shockingly, it's the input context ingestion, not the output generation, that actually drives this massive, bloated overall cost.
To understand why this happens, we have to look at the O of n squared trap, which is perfectly captured here by Arahant Deva. Naive agent loops continuously rebuild prior context on every single API call. Think about it. If an agent runs a 10-cycle reflection loop, it has to repeatedly read the user request, the system prompt, the tool outputs, and all of its own past reasoning, over and over. It compounds quadratically. A 20-step loop can easily consume 50 times more tokens than a single pass.
This introduces what we call the stochastic or random nature of agentic costs. Get this, if you run the exact same task twice, you might see a 30x variance in tokens used. Why? Because of tool invocation behaviors and multi-turn state drift. Basically, the agent pulls a tool, echoes the tool schema back into the context, reads the output, and maybe just gets confused. It explores unproductively. And importantly, as the data definitively shows, spending more tokens absolutely does not guarantee higher accuracy. Often, the accuracy peaks early, and then all that excess expenditure just reflects a confused model draining your budget.
All right, Module 3, the AI gateway layer, centralizing control. The crucial question is, how on earth do we rein in this chaotic spending?
You absolutely, categorically, must establish an operational gateway layer to eliminate shadow AI and secure your LLM infrastructure. We're talking about deploying platforms like OpenLM, TrueFoundry, or LiteLLM. You need strict token-based traffic controls that implement leaky bucket algorithms. This means setting hard limits on tokens per minute, enforcing active data loss prevention, and building per-trace budget circuit breakers. When an agent inevitably goes rogue, your gateway needs to gracefully degrade the system, returning detailed, machine-readable 429 RFC 7807 problem details. This effectively pauses and queues the running agents before they bankrupt the department. Oh, and furthermore, integrating schema standards like Focus version 1.2 through 1.4 Plus and OTel conventions ensures your telemetry is completely unified across the entire enterprise.
But gateways aren't just for blocking bad requests. Intelligent platforms also use smart and dynamic routing. By actively analyzing a query's embedding fingerprint at runtime, the gateway evaluates how complex the task actually is. It then automatically routes that task across your enterprise model hierarchy. So it sends simple summarization jobs to a cheap economy tier model and saves the heavy reasoning tasks for your premier flagship models. It's incredibly efficient.
Next up, Module 4, Advanced Semantic Caching, Optimizing GPU Waste. Let's tackle system optimization and solve the massive GPU waste caused by redundant system prompts.
Let's contrast two approaches here. Basic prefix caching, like the kind you see in inference engines like VLLM, maps out key value states to save GPU flops. That's great, but it relies on exact token matching. So if one user asks, "What is PyTorch?" and another user asks, "Tell me about PyTorch," prefix caching completely fails to match them. Semantic caching, on the other hand, maps meaning based on vector embeddings inside vector engines like Redis or FAS. By calculating cosine similarity, it actually recognizes the user's underlying intent, even if the phrasing is entirely different. And this brilliantly illustrates the semantic forest concept, which is utilized by systems like SmartCache. Here, conversation turns are hierarchically organized. It isn't just looking blindly at the current question. It ensures cached responses match both the semantic query and the preceding conversational context. However, and listen closely, because as an architect, you must be extremely vigilant here. Adversarial inputs can trigger semantic cache poisoning attacks or key collision vulnerabilities. This is where bad actors trick the similarity evaluator into serving toxic, falsified cached payloads. Strict validation countermeasures for your cache are absolutely mandatory.
Let's ground all this in some hardcore production metrics. By dynamically monitoring internal LLM attention scores during the prefill stage, SmartCache can effectively navigate complex topic shifts. And the results are just astounding. It cuts time to first token by up to 78% and slashes heavy key-value cache memory usage by 59.1%. This right here is exactly how you optimize the algorithmic serving cost at a true enterprise scale.
Moving to Module 5, Dual-Brain Hybrid Architectures, Edge Cloud Loops. For our ultimate infrastructure move, we're going to architect a network that completely decouples local memory from expensive cloud compute.
Here is your precise edge cloud loop, step by step. First, you maintain a sovereign, local librarian. You vectorize your project history into a local 768-dimension retrieval-augmented generation database. Second, you use a local model context protocol, or MCP server, to actively scan and query that data with ultra-low latency. You are only extracting the exact vectors you need. Third, you combine that tight, highly relevant context with the user prompt and push it securely through a local WSL2 proxy gateway right up to a high-reasoning cloud model.
Why is this so powerful? Because this architecture fixes the bloated monolith problem. Instead of a massive central node holding all the data, you create a decentralized agent-to-agent network. By keeping your memory on your own hardware, you completely bypass those central API toll booths, you eliminate the massive per-token fees caused by context bloat, and you can securely proxy your heavy logic tasks through flat-rate consumer web subscriptions. Basically, you own your memory locally, but you get to leverage cloud intellect for free. It's a total game changer.
Finally, we've arrived at Module 6, the AI FinOps Future, Strategic Tokenomics. Let's look at what this all means for the overarching strategy of your business. Here's the big takeaway. Managing tokens is absolutely not just an engineering footnote anymore. As the tokenomics frontier perfectly puts it, it is FinOps applied to AI. This is a CEO-level economic discipline. The goal isn't just to minimize token consumption for the sake of it. The goal is to connect that consumption directly to real business value. Your finance team needs to see, measure, and govern tokens with the exact same rigor that they apply to cloud computer storage.
So, I want to leave you with this one very powerful final thought to evaluate before you push your next deployment. When you look at your AI bill this month, ask yourself, are you actually paying for valuable compute and intelligence? Or are you just blindly paying for unproductive exploration and redundant context loops? Master your tokenomics, lock down your gateways, and take back your infrastructure. Thank you so much for joining me on this explainer, and I'll see you all next time.